Hi, my name is Jody, and today we'll be learning about translating word sentences to equations. We have one objective, and it is to translate sentences to equations using keywords, then solve. So for our only objective, first, let's recall some keywords and their translations. So here I've listed keywords in one column and their answer words in the second column. So for instance, sum is the key word to remind you of the mathematical operation of addition. Difference is subtraction. Product is multiplication. And quotient is division. When you hear a word sentence and you see a phrase containing one of the key words, sum, difference, product, or quotient, and the word and, that word and lets you know that you're supposed to do the mathematical operation indicated by that keyword. So for example, translations for addition and subtraction, if you see the phrase, the sum of x and 3, sum is the key word for addition, and the word and is replaced by the mathematical symbol for addition. Difference of x and 3, the word and gets replaced by the mathematical symbol indicated by the word difference. For product and quotient, multiplication and division, we have similar translations. The product of x and 3, the word and becomes a multiplication, x times 3, and the quotient of x and 3, the word and becomes a division symbol, x divided by 3. Another thing we'll need to know are the keywords for an equal sign. So we will use an equal sign when we're translating if we see any of the following keywords: is equal to, is the same as, is, produces, yields, or results in. Let's try an example. 12 less than a number is 10. And we will translate this to an equation, then solve. So I will let my number be lettered n, and I have to translate this to an equation. The word is my equal sign. So I have equals 10. 12 less than a number. Less than is a key word for subtraction. My number is n, so I have n minus 12 equals 10. So now I'll solve this, and I will need to add 12 to both sides. So I have n plus 0 equals 22. So n equals 22. So my number is 22. Let's see another example. This is one that you'll try on your own. 4 more than the product of 5 and x yields 14. And you should translate this to an equation and then solve. So pause the tape and try this problem. Okay, let's see how you did. 4 more than the product of 5 and x yields 14. So the word yields tells us to use an equal sign. So on the right, I have equals 14. On the left, 4 more than tells me addition. So I'll have plus 4. And it's 4 more than the product of 5 and x. So here we're seeing a phrase where the word product is our key word, and the word and tells us that we're going to have 5 times x. And in the phrase, this was 5 and x. The word and is replaced by the symbol indicated by product. So we have 5x, 5 times x plus 4 equals 14. We solve this. We will subtract 4 from both sides. And we have 5 times x plus 0 equals 10, or 5x equals 10. And to isolate the x, I will divide both sides by 5. And I'm going to move over here. 5x divided by 5 is 1x. 10 divided by 5 is 2, so I have x equals 2. And that is my solution. Let's see one more example. And in this example, we're going to be given a word sentence and a translation which will be incorrect. And we will try and find the mistake. Explain the mistake in the translation. Then write the correct translation. 2 times the sum of x and 13 is equal to negative 9. Okay. And the translation we are given, which is incorrect, is 2x plus 13 equals negative 9. So what I will do is I will try to think about the correct translation and then see where the error occurs. So 2 times the sum of x and 13 is equal to, there's my key word for equals, negative 9. So I have my right-hand side, and that's fine. 2 times the sum of x and 13. So let's just look at this phrase, sum of x and 13. That's a phrase where I see the word sum, which is a key word for addition, and the word and. So I'm going to have x plus 13. Before that, I see 2 times. So that says I want twice that entire amount. Now we can see where the mistake in the translation is. The order of operations indicated by the sentence is not reflected accurately in this translation, 2x plus 13 equals negative 9. You can see by the wording, 2 times the sum of x and 13, that we are asked to add x and 13 before we multiply by 2. So the error here is in the order of operations indicated by the word sentence. Okay, so today we talked about translations and translating word sentences to equations and then solving them. So be sure to practice some more exercises, and if you're having trouble, ask your instructor, and good luck. Hi, I'm Jody, and today we'll be using what we learned in a previous section about translating word sentences to equations to solve applications. We have 2 objectives. They are to solve problems involving 2 unknowns and use a table in solving problems with 2 unknowns. For our first objective, we'll need to recall the definition of perimeter. The perimeter of a shape is the length around all sides. And we'll also need the definition of isosceles and equilateral triangles. So an isosceles triangle is a triangle with 2 sides of equal length. And an equilateral triangle is a triangle with all 3 sides having equal length. So let's see an example. This is an application problem. A sculpture in front of a school has an equilateral triangle sitting atop a rectangle. All sides of the equilateral triangle are the same distance as the width of the rectangle. The length of the rectangle is 10 feet less than 3 times the width. The perimeter is the same for both shapes. What are the dimensions of the shapes? Since this is an application problem, we'll need to use the 3-step problem-solving process: understand, plan, and execute. So for understanding the problem, we've read it, and let's make a note to ourselves that we're asked to find the dimensions of the shapes. So we'll need the length of each side of the equilateral triangle, and those lengths will all be the same because it is an equilateral triangle, and the length and width of the rectangle. So also for understanding the problem, we'll go through and identify some key pieces of information. We are told that all sides of the equilateral triangle are the same distance as the width of the rectangle. Okay, so that's important. And we're also told that the length of the rectangle is 10 feet less than 3 times the width. That's important too. And the perimeter is the same for both shapes, and that will be important also. So I guess I'll underline that as well. And now what I'm going to do is go onto a new sheet of paper, and we'll draw a picture and label it, and then attempt to solve this problem. So here I've written some of the important information. The length of the rectangle is 10 feet less than 3 times the width, and the perimeter is the same for both shapes. So we're told that we have a rectangle with an equilateral triangle, and I'm going to label each side of the equilateral triangle with the letter S. And we're also told that the width of the rectangle is the same length as the side of a triangle. So I can label these two sides S. And the length of the rectangle I can label L. I'm told that the length of the rectangle is 10 feet less than 3 times the width. So I'm going to translate this word sentence into an equation. The length of the rectangle is L. The word is a key word for equals. 10 feet less than, so I'm going to have something minus 10, 3 times the width. So that would be 3 times the width. I've used the letter S to represent width. Okay. The perimeter is the same for both shapes. So let's write equations for the perimeter of each shape. So for the perimeter of the triangle, that's going to be S plus S plus S, or 3 times S. The perimeter of the rectangle is S plus L plus S plus L, and I will replace or substitute 3S minus 10 for L. S plus 3S minus 10 plus S plus 3S minus 10. And combining like terms, I have S plus 3S plus S plus 3S, which gives me 8S. Minus 10 is minus 20. So I have the perimeter of each shape, and I'm told that the perimeter is the same for both shapes. So I'll set those equal to each other. 3S equals 8S minus 20. And what I will do is subtract 8S from both sides. To get negative 5S equals 0 minus 20. Negative 5S equals negative 20. To isolate S, I will divide both sides by negative 5. So I have S 1 times S equals 4, or S equals 4. So 4 is the width of the rectangle. We'll go back to the picture. So each of these S's is 4. And in order to find the length that will complete the problem, I can substitute 4 into this equation for L. L equals 3S minus 10. And I'll do that right over here. L equals 3 times 4 minus 10, or 12 minus 10, or 2. So I have the length and width of the rectangle and the length of all the sides of the equilateral triangle, so I've completed the problem. For our second objective, we'll be using a table to solve problems with 2 unknowns. And we're going to be using a specific kind of table, so I'd like to show you the columns of that table. In this table, the columns are categories, value, number, and amount. Under the categories column, that's just telling you what your unknowns are. So I'll do an example. Let's say that your category is movie tickets. So you have tickets for a particular movie. Value would be the cost of the ticket. Number would be how many you sold. And then the amount would be the total amount of money you made by selling all those tickets. And we have the equation value times number equals amount. Okay, so this is the table that we'll be using, and let's try an example. Jasmine sells 2 sizes of holly shrub. The larger size sells for $7 and the smaller size for $5. She knows she sold 16 shrubs for a total of $94, but forgot how many of each size. How many of each size did she sell? So this is an application problem, and we'll use the understand, plan, and execute problem-solving approach. So for understanding the problem, we've read it, and we need to find out how many of each size she sold. So there's 2 sizes, and we need to decide how many of each she sold. We're going to use the table, so we need to fill in values from the table. And let's make a note of one thing. Let's let S be the number of small shrubs she sold a total of 16. So 16 minus S, or 16, and then take away the number of small shrubs that were sold, will be the number of large shrubs. Okay, so using this, we can fill in the table. So my 2 categories are small shrubs and large shrubs. Value is the cost of each of those, and we're told that the small shrubs are $5 each and the larger shrubs are $7 each. The number of small shrubs that she sold is S, and large shrubs she sold 16 minus S. We use this equation to fill in for amount. So 5 times S is the amount for small shrubs. 7 times 16 minus S is the amount for large shrubs. The total amount of money that she has is $94, and that's a combination of what she made from the small shrubs and what she made from the large shrubs. So if we add 5S, the amount she made from the small shrubs, to 7 times 16 minus S, the amount she made from the large shrubs, we'll get 94. In other words, we have the equation 5S plus 7 times 16 minus S equals 94. And we'll need to solve that equation. So the first thing I will do is distribute this 7. 5S plus 112 minus 7S equals 94. On the left-hand side, I will combine like terms. 5S minus 7S gives me negative 2S plus my 112 equals 94. And now I will subtract 112 from both sides. So I have negative 2S plus 0 equals negative 18. To isolate S, I divide by negative 2. 1S equals 9. So S equals 9. So she sold 9 small shrubs. Let's go back to the question. She sold 9 small shrubs, and 16 minus 9 would be 7. So she sold 7 large shrubs. And that's the answer to that problem. Okay, so we've seen examples of solving equations with 2 unknowns using a table as our second objective. And you should be sure to practice more problems from your textbook. And if you're having trouble, be sure to get help as soon as possible. Good luck.